So we spoke about particular second degree equations. Now we are going to talk about them in general. First, they are polynomials of this form: ax squared plus bx plus c. Okay, so let's say we have 3x squared plus 2x plus 1. This is called a second degree polynomial. We can also call them quadratic polynomials, second degree or quadratic polynomials. Okay, so how do we solve equations that have quadratic polynomials in them, or how do we solve equations of second degree? Okay, as a start, there is a new tool, something that we need to memorize well. It's called delta the discriminant. Okay, it's called the discriminant, or we can call it delta. The symbol is called delta. Okay, what is delta? It equals b squared minus 4ac. We just memorize this, and depending on the answer of delta, we can determine how many solutions are for this equation. Okay, for any second degree equation, we need to memorize that delta equals b squared minus 4ac, and if delta is positive, we get two roots. If you recall from last year, depending on the degree of the polynomial, we can determine how many possible roots that we may have. If it's of power 2, the choices are no roots, one root, or two roots. So if delta is greater than 0, we get two roots. Let me write them down. Then the equation will have the first root, x1 will equal minus b. Okay, I need more space. X1 will equal minus b minus radical delta over 2a. The second one will be exactly the same, but plus in the middle. Okay, so if the answer of delta is positive, we get these two roots. We say that the equation has two distinct real roots. So basically it has two roots, and to calculate them we use these rules: minus b minus radical delta over 2a, minus b plus radical delta over 2a. They might seem confusing or difficult, but they are just these two rules basically. Okay, for now. Now if delta is negative, it's my favorite one. If delta is negative, then it has no roots. Okay, it simply has no roots. There is no number that we can substitute with x that gives us 0 in this case. Okay, and the final one is if we have delta equals to 0, then we get one double root, which basically means for now that we have one root for the equation. Okay, and how do we find this? It's actually very easy. We say, because one double root, we say that the first one and the second one are equal. x1 equals x2. It's like the root is being repeated two times. Okay, it's the same but repeated two times. x1 equals x2. You use the same equation, but you know that delta is 0, so radical delta will be gone in the case below. So you will get minus b over 2a only. Okay, so let's try to solve an example. Let's say we have x plus one that we already know, x squared plus 2x plus 1 equals 0. we solved this before. We found that -1 is the root. It had only one root, so it will probably be, which case? The last one, because it has one double root. So let's try to check. First we use delta. This gives us b squared minus 4ac. What are b and a and c? They are the coefficients of the second degree equation. A is the one besides x squared. Okay. B is the one besides x, and c is the constant. So in this case, let me write them above them. What is a? It's 1. What is b? It's 2. What is c? It's also 1. Okay, you can start by writing them down so you're not confused when substituting. Let's do that now. B squared is 4 because it's 2 to the power 2 minus 4. A is 1, C is 1, so we get 4 minus 4, which gives us 0, which also means the equation, let's use implies, the equation has one double root, which is x1 equals x2 equals minus b over 2a, because we need to memorize these rules. Basically the whole lesson is just memorizing this these rules. Delta equals b squared minus 4ac minus b minus radical delta over 2a minus b plus radical delta over 2a, and the cases delta positive gives you these two, delta negative gives you no roots, delta equals 0 gives you minus b over 2a. So simply you just need to memorize these 2 pages for now and you can solve anything. So let's go back. Minus b is minus 2, 2a is 2 multiplied with 1, so minus 2 over 2, so it gives us minus 1. And notice we got the same answer that we had when we used the remarkable identities. But the thing is, we can't always use the remarkable identities, so we need to use delta, the discriminant, and these rules. Okay, I'm going to solve one last one. Let's say we have x squared plus x plus 1 equals 0. Try to solve it with me or on your own. First we start by finding a, b, and c. A is 1, b is 1, and c is 1. Start by using delta, b squared minus 4ac. We need to know the answer for delta to determine the roots. B squared means it's 1 to the power 2 minus 4, a is 1, c is 1. So we get 1 minus 4. This gives us minus 3. We check the cases. It's not positive, it's negative. So what do we get? We have no roots. So delta, let's say right over here that delta is negative. So the equation has no roots. It's as simple as that. You just need to memorize these 2 pages and their rules, and you can solve any equation.